Hello and welcome back to Data Analysis and Visualization. I'm Jovita Christie, and in this video, we are going to see some theory and equations for polynomial and multivariate linear regressions. And we are also going to see how to implement that in Python using a real data set. So let's begin. We'll start with polynomial regression. So a polynomial regression is a type of linear regression in which the relationship between the independent variable x and the dependent variable y is modeled as an nth degree polynomial. So when you want to model the relationship as an nth degree polynomial, remember that for a simple linear regression, the polynomial that we had was y is equal to mx plus c, or y is equal to ax plus b. And in that case, what we had was a polynomial which is not an nth degree polynomial. So in this, what is an nth degree polynomial? We're going to see that now. But why do we need it? We need it mainly when we cannot fit our data with a 1 degree polynomial where the data does not fit on one single line, and you might want to have curves in your line. So that's where we use a polynomial regression. And you can see this is the type of data that I want to fit. And probably for this kind of data, if I were to use a simple linear regression with one straight line, then there would be a lot of errors, random noise, and that wouldn't be a very fit model for this kind of a data. So polynomial regression would fit a non-linear relationship between the values of x and the corresponding outputs or dependent variable y. So when your variables look something like this, when your x and y look like this, the blue circles that you see here, then it seems fitting to create a curved non-linear relationship instead of creating a straight line, which is a simple linear regression. So this is where you would want to use polynomial regression, and that's what we're going to do in this unit. So this is the equation. You can see here it is y is equal to m1x. So earlier it would have been simply y is equal to ax plus b, or y is equal to mx plus b. You can see that's already present. B is present here. Okay, b is present right here. And you can see, if you remember, b is the y-intercept in our graph, which is present. And the slope is present, but there are many slopes. The reason for this is because the line is not a straight line. If it's a straight line, there will be only one value for the slope. But because our line is curved, we have multiple slopes, and which is why we have m1, m2, m3, and so on up to mn. And the values and x's every time has a different degree. So you can see this is x, this is x squared, x cubed, and so on up to x raised to n. And n represents the order of the polynomial. So that's why it is an nth degree polynomial. And now we're going to see how to implement a polynomial regression using Python. So this is the notebook that I'm using for polynomial regressions. You can pause the video if you would like to run the code, implement the code on your own machine. And if you want to use the CSV file that I'm using in this video, you can. There are two files actually, so both of them have been linked in the description box. You can access the link from there. And let's begin. So there is polynomial regression, and there are three libraries being used right now, which are NumPy, Pandas as usual, and the matplotlib to create the plot. So we will be referring NumPy as NP, matplotlib as PLT, and Pandas as PD. And this is the link to the file that I was talking about. It contains some values like temperature and pressure. So based on the temperature, if you can find out the pressure. Okay. So temperature is your independent value and the pressure is your dependent value. So, and it's a very small file, contains only about 6 rows. So that shouldn't be very difficult. Now, it's just for practice purposes. And then I think by now you know what this function does, bd.readCSV. It is going to read this file and create this data frame. And then from the data frame, I'm just displaying what the file contains. So like I said, it's a small file, shows the temperature and the corresponding pressure. So for this, we are going to create a polynomial regression curved line, not a straight line. Now to do that, first of all, we have to extract our x values from the temperature column. And we are going to be using this function of data frame called iloc. iloc allows you to fetch, and you would be probably knowing this if you have already gone through pandas. So iloc allows you to fetch certain values from certain rows and columns. So that's what's happening here. I'm fetching those values from a two-dimensional array sort of a thing. And you can see this is the first value that I'm specifying because I want everything. And this basically specifies the column, and that way I can get temperature. From temperature, I can get 0, 20, all these values right here. They will be saved into the variable x. And then we have the variable y, for which I only want the pressure. So once again, you can get it by doing this. You just put a colon, which means you're getting all the values, and you want all this, and then you specify the column that you want, and that's it. So this is how you can get this SNO, which you see, it is just a serial number, so don't bother about that. And this index you see is right here is given by the pandas library itself. So so this also you shouldn't bother about. So the main two columns are temperature and pressure. And for this, we are going to create a curved line. So you can see that, let me just run this once. Okay, that is done. And this is what X contains. Let me show you what X contains. So X contains this array, which contains 0, 20, 40, 60, 80, and 100, just the way we want it. And you can see it is two-dimensional because whenever we are passing the value inside our linear regression model, it requires this type of a two-dimensional array, which is why it looks like this. And let me also show you why. So let's print y as well, so you get to see it. So this is y. You can see it here. This is not two-dimensional because for the y values, we do not need to pass a two-dimensional array in the linear regression model. So of course it has converted the values like this, but you can match up with the original ones and you'll understand. So this is these are the values of x and y. And now let's proceed towards how you can fit the exact polynomial regression to this data set and use the components x and y which we created here. So we are going to be importing the linear regression model from sklearn in this manner. And we are also going to be importing polynomial features from preprocessing of sklearn because we need to do a polynomial regression and not a linear regression. So once that's done, now we are going to call this object. We are going to create an object, and in that we can specify the degree. So I'm going to specify degree 9. You could specify any degree basically. The reason for this degree specification is that you want to show how many degrees your curve should have. So remember I just told you the equation, which is an nth degree polynomial. So you're just specifying the degree. You want 9, so it would go up to x raised to 9. That's what would happen. And this is This is created. Now we are creating the model. To do that, we are just going to do fit underscore transform and pass the values of x into it, and that would create these polynomial features and store them in model underscore poly. And then we can use the linear regression as we did in one of the previous videos, which we did, where we implemented a simple linear regression for Olympic 100-meter race. So in this case, we are using this lin underscore poly, and we are creating an object called lin underscore poly of linear regression. And then we are just calling the dot fit function, which we, as we did in simple linear regression, where we pass x and y. In this case, instead of x, we are going to pass this model underscore poly. And then we have y as it is. And let's just run that as well. And it's just going to give you, as a result of this, because we have not plotted anything yet, it's just going to give you this, this line here. Now, that means it just ran successfully. There were no errors. And now we can plot it. So in order to plot this type of a regression, first of all, we are going to create a scatter plot of the original data. The original data is simply x and y. So we are just going to give it a blue color, and you can see all these dots appearing here. Those dots are actually part of your original data. So this is the original data. The dots are appearing. And the second thing we are doing is plotting the predicted thing. So we are going to predict over here this thing. We have to predict this red line that you see based on the values of x and y. We need to predict this line, which is why we are using the dot predict function. Okay, and there we are going to pass the model underscore poly, these values that we found here, and that is passed here. The color is red, so you can see this red line that traces all these dots and creates this whole curve that we have done. And of course, the title of this plt.title is to give this title of polynomial regression, x label for x-axis label, which is temperature, and the y label for y-axis label, which is pressure. So multivariate linear regression is when you have multiple x variables, multiple independent variables on which y depends. And you can see it in this type of a table. You can see there is x1, there is x2, and then there's one y column. So there are multiple x variables, independent variables, and you want to predict y using those independent variables. In this case, you cannot use simple linear regression, which is used only when there's one independent variable and one dependent variable. So because we want to create this in such a way that we want y to be predicted by multiple variables. Okay, so we have multiple columns here. Okay, we have multiple columns here for our input, and this means our output y would now be dependent upon more than one independent variable. So this is where we use multivariate linear regression. And this is what the graph of this type of a regression looks like, because there are multiple multiple values of x. There's x1, x2. So this is a graph where there is horsepower and weight. So this is about vehicles, cars, and you can see this is a horsepower which is plotted on this axis. Weight is plotted on this axis, and mpg, which is miles per gallon, is plotted on this axis. This is our dependent variable, and we have two independent variables, weight and horsepower, which is why it is a sort of a 3D image, as you can see. So these dots that you see, those are the actual data points, and this sort of a mesh kind of a thing that you see in the middle, those boxes that you see, that is your plotting of the regression. So this is what we are going to do, but using a program in Python. This is the equation of it. You can see here. This is the equation. which is y is equal to fx, which is equal to b. B is your bias as usual. And instead of m, we are going to be using w in this case. So w1, w2, and so on up to wn. And this is basically equal to wi xi sigma n equal to I equal to 1 up to n.